All right, you'll have your chance in a moment. I'll take some questions from the audience here. But our goal for today is that we are going to define and classify special types of parallelograms. And we're also going to use those properties to solve things. So take a gander here, and similar to this question here, all rectangles are parallelograms. Look, a rectangle is a parallelogram. But if we go the other way, only some parallelograms are rectangles. A parallelogram might be a rhombus, it might be a rectangle, or it just might be a parallelogram, nothing special. So from the audience, I'll take a few comments. What sentences did you come up with? Then a square as a rectangle does work, but we could also add more to it, but a rectangle is only sometimes a square. So someone could argue, and that could be a sentence over here. So today what we're going to do is focus all our attention on these three right here. These are special parallelograms. One is called a rhombus. One is called a rectangle. And when they combine to have babies, they're not called rectus. Rather, it's called a square. Let's review vocabulario. And this is by review. Number one, parallelogram. It is any quadrilateral with two pairs of opposite sides that are parallel. Yay, word to your grandmother. Yay. Yay. So, parallel there, parallel there. As we look at these definitions, here's the key. Trickle-down properties. Trickle-down properties. Everything that's true here oozes down to everything that's there. Which also means everything that's true about a parallelogram will ooze down. So since a parallelogram has opposite sides congruent, opposite sides congruent here, opposite sides congruent here, opposite sides congruent down there, opposite angles congruent, opposite angles congruent, opposite angles congruent, diagonals bisect each other, diagonals bisect each other. So everything we've already stated here trickles down. Everything we state about an irregular will trickle down here. Everything that's true about a trapezoid is also true about an isosceles trapezoid. So let's see. Here's an additional two properties of rhombuses, or rhombi, if you want to be all Latin. By the way, it's every other property above, too. Everything we talked about parallelogram previously is also true here. But more specifically, the diagonals of a rhombus are perpendicular.
I knew that.
And that's it. So when I make a perpendicular here, now I think the diagram might not look all that great because of the way the projection is occurring. But there we go. That is what is true. So AC is perpendicular to DB or BD. Which means, what else do we know about the diagonals here based on the previous thing? So please tell your neighbor, what else do we know about diagonals based on the fact it's a parallelogram? So here's something else about diagonals, and this one's a little bit more wordy. So the diagonals of a rhombus each bisect opposite angles. So it's a little bit harder to demonstrate this because of overlapping diagonals, etc. But this blue diagonal is going to cut this angle in half and this angle in half. And if I do BD here, it's going to cut this big angle, which was formerly called D. Angle D, the big one, is now cut into two that are congruent. And the same is true over there. They're not necessarily congruent everywhere, but certainly opposite stuff gets cut in half. Yep. All right, on A here, we're finding the measure of each numbered angle here. And we are told that this is a rhombus. So if you wanted to mark it as a rhombus, you could. But it tells us in the instructions it is. Which means, because this is a diagonal, I know that this angle is bisected and also congruent over there. So I know that the measure of angle 1 is 38 degrees. So how are we going to find anything else? How are we going to find anything else? The way to approach it is to look at this triangle and say, oh, the sum of the measure of the interior angles of a triangle sum to 180, so this one also has to be 38 right here. So therefore, we can subtract the 76 from 180. So 76 plus 180 equals, sorry, not 180. There we go. And finally, the measure of angle 2 is equal to 104. Great. So the next and last property we're going to look at today is that the properties of rectangles specifically. And it turns out that the diagonals of the rectangle, and any rectangle, are going to be congruent. So we can place that in there. And so it turns out that BD, segment BD, is congruent to segment AC. The diagonals are congruent. Now remember, properties of rectangles include all the properties of every parallelogram. So we know that opposite sides are parallel, we know opposite sides are congruent, all these things, and in addition, we know that the diagonals of the rectangle are congruent. So just walking through an example over here, if LN, and as we look over here, LN is a diagonal, and MO is 2x plus 13. What are the lengths of the diagonals of this rectangle? Well, since the diagonals are congruent, we can easily set this one up to say 4x minus 17 equals 2x plus 13. So 2x equals 30. X is 15. Remember, this is not my answer. What I need to do is take the 15 and substitute it back into one of them, and it doesn't matter. So if I substitute it into the 2x plus 13, then I get 30 plus 13. So my answer ultimately is going to be 43. Each diagonal is 43. We want to look at the 6 properties of squares. Now remember, there are more than them, but they also are so specific it supersedes others. So for example, all sides are congruent are its rhombus heritage, the heritage of being a rhombus. So it is true that opposite sides are congruent, but more specifically, all sides are congruent. It's true that opposite angles are congruent, but more specifically, all angles or interior angles are right angles. So not only are all the angles congruent, but all the angles are right. So this supersedes the opposite angles are congruent. Good. So in terms of its rhombus heritage, we know that diagonals bisect a pair of opposite angles. So this is a rhombus heritage. This is a rhombus heritage. This one right here is a rectangle heritage. Also rectangle heritage, diagonals are congruent. So in the parallelogram heritage, we know that diagonals bisect each other. And learn to spell each. There. And good. And also parallelogram, opposite sides are parallel. And that is the heritage of parallelogrammage. Good. So being even more specific, and we'll add that in there, not only are diagonals bisect each other, but the diagonals are perpendicular bisecting of each other. And that's actually the heritage of both rhombus and parallelogram.